Hello everyone and welcome to another video with Special Maths Academy. In this video, we'll be looking at the 22nd problem from the Special Maths Contest 2023 first round. So let's go into this question. It says an octagon of perimeter 32 units is such that four sides have equal lengths of 3 units and remaining four sides have equal lengths of 5 units as well. Order does not matter. Given that this octagon is cyclic, find its second radius. Okay, so order does not matter. This is an interesting concept. So how can we, attack this problem? So something that's it's important to note is extended law of sines. So I'm going to write that. Okay, so let me increase the thickness of my pen. So extended law of sines. So if you have a circle and you have a random chord, so let's say A, then whatever angle this chord subtends, say theta. Okay, so we'll have that A over sine theta is equals to 2 times the radius of that circle. Okay. Okay. So I'm going to apply that here. So what does that mean? Since order does not matter, it means each of the 3 units of so each of the 3 units subtend equal angles, because we can express, so by the external law of sine we can express sine theta. So sine theta is equal to A over 2R. Okay. Because what this means is that each of these chords, so once we know the chord and we know the radius, we can get the angle that that chord subtends. So each of the 3 units chord subtend an angle of, theta, and we can say each of the 5 units chord subtend an angle of alpha. Like, yeah, those angles are equal. But now, can we find those angles? Okay, so we can we can consider, okay, the angle at the center in this case. So 2 theta. Something like that. So now, if we consider the angle at the center, we'll see that, okay, so let's 3 units chord subtend an angle of 2 theta at center. And then analogously, let's 5 units chord subtend an angle, okay, so I'll call this alpha, of 2 alpha at center. Okay, so now what can we say? Since these chords form an octagon which is cyclic, it means we're going around the circle. So it means we have 4 3-unit chords. So we have 4 into 2 theta. And we also have 4 5-unit chords. So plus 2 alpha. So this should give us 360. Okay. What does this give us? Alpha plus, so theta plus alpha is equals to 45 degrees. Okay. So because 360 divided by 4 is 90 degrees, then we divide it again by 2 to get 45 degrees. Okay. So now we have that the angle subtended by the 3-unit chord and the angle subtended by the 5-unit chord form an sum up to 45 degrees. So now we can just, draw the circle. We can remove the octagon. We can just draw the circle now. So this is why order does not matter. Okay, so people wonder, order does not matter. This is why order does not matter. Because now we've thrown away the octagon, we just have the circle. So first of all, we draw, let's say this is a 5-unit chord. Let's say this is 3 units. Okay. And then we have that. So let's just pick a random point. We have that the angle is subtend at the circumference. So the angles are subtend at the circumference. Oh no, let me bring in the center. Okay, so since theta plus alpha is 45 degrees, so it means theta plus, so 2 theta plus 2 alpha is 90 degrees. So it means the angle that is obtained at the center is 90 degrees. Okay, so this is 90 degrees. So we have R, 5, 3. Now we need to find this angle. So it's very important. So since we have this is 90 degrees, it means this angle here is what? 270 degrees. Okay. We know angle subtended at the center is twice angle at circumference. So it means this angle here is going to be what? 135 degrees. Okay. So I'm going to bring that diagram out. So we have something like this. Okay. We have the radius R, 135 degrees, 3, 5. Okay. So we have R and R. So we can use Pythagoras theorem to get that this diagonal in this quadrilateral. So let me just leave it the quadrilateral. So this here is the center of the circle O. So let me just call this A, B, C. Okay. So this diagonal AC is going to be 2 root, R root 2 rather. So by Pythagoras theorem. Okay. So I don't need to spend much time on that. Now we can apply cosine root to triangle ABC. So we have R root 2 all squared equals to 5 squared plus 3 squared minus 2 into 5 times 3 cosine 135 degrees. Okay. So R root 2 squared is 2R squared. 5 squared is 25. 9 squared is, and 3 squared is 9. So minus 2 times 3 times, 2 times 5 times 3, that is 30. Cosine 135 degrees is negative cosine 45 degrees, which is negative 1 over root 2. So I'll just put root 2 over 2. Okay. This is equal to 25 plus 9 is 34. And then this is minus 15. So this will be plus 15 root 2. Okay. So what do we have? We have R is going to be equals to the square root of 34 plus 15 root 2 divided by 2. Okay. So sorry, this should be all divided by 2. Yeah. Okay, so 34 plus 15 root 2 all divided by 2. And that is D. Okay. So you can see it, option D. I hope you learned something new from this video. Don't forget to share, like, comment, and subscribe, and see you in the next video. Goodbye.